Hello, Junior 3. Open your books on page 5. Let's make a quick recap about riddles. We said riddle is a question or a statement that has multiple meanings and needs to be solved. Number 1, we here are talking about a number that's less than 10. And when we add this number 3 times, it gives the number 15. We said that this number is 5. How did we solve this riddle? We looked for all the possible answers and we used math by adding numbers to see which number, when we add it 3 times, gives the right answer. Number 2, I am a unit of measurement. I measure the length of an object. I'm useful for measuring the length of a paper clip. What am I? Unit of measurement means when we say I am 20 kilograms, kilograms here is a unit of measurement. When I say the building is 50 meters, meter here is a unit of measurement. So the paper clip is a short object, so the answer of the riddle is centimeter. How did we solve this riddle? Thinking about units of measurement that can measure short objects. We used a strategy today to solve those riddles. Let's explain the word strategy. Strategy means a plan or method used to get an answer. So the strategy we used today was brainstorming. Brainstorming means gathering ideas. So the strategy was brainstorming because we gathered a list of ideas. Open your books on page 6, run and jump. Before we start our lesson, let's talk about measuring units. First we have kilogram. We use kilogram to measure mass, like your body weight. Second we have meter. Meter is used to measure long distances. And the last one is centimeter. We use centimeter to measure short lengths. Here we can see an athlete who's competing in an event. He runs down the track and then jumps at the line. What questions can we ask about what's happening? There are a lot of things we could measure in this photo. What's measurable? We have an example here. How far did he run? What else can we ask? How far did he jump? What else? What's his weight? We use kilograms to measure weight. And the last question we have, what's his height? We use centimeters to measure height. Open your books on page 7. Let's read the title. How far can we jump? This is an activity you can do it at home. Let your family members help you. Stand with both feet on a line like the boy in the picture and jump forward as far as you can go. Have a member of your family to mark where your feet landed and another family member measure the distance of your jump. Record it here. Second part of page 7, Miss Sarah asked 15 of her students to jump. She recorded the answers and put it in this table. So, 3 students jumped between 0 to 40 centimeters. 5 students jumped between 41 to 80 centimeters. 4 students jumped between 81 to 120 centimeters. 2 students jumped between 121 to 160 centimeters, and only 1 student jumped more than 160 centimeters. So Miss Sarah here was collecting data. Now she needs to present it. What should she do? Look at page 8. Here in this page, we have a table about a group of athletes competed in a jumping event. Students collected data about them to answer the question, how high can an athlete jump? Look at the measurements they collected. This is how we collect data in a table. We have 10 athletes jumped between 0 to 50 centimeters, 7 athletes jumped between 51 to 100 centimeters, 2 athletes jumped between 101 to 150 centimeters, and only 1 athlete jumped between 151 to 200 centimeters. Every graph has this line. This line represents the range of the height of the jump of every athlete. The first graph, we use X to represent one athlete. The first range from 0 to 50 centimeters, we have 10 athletes, so we will put 10 X's. Second range between 51 to 100 centimeters, we have 7 athletes, so we will put 7 X's. The third range, we have 2 athletes that jumped between 101 to 150, so we will put 2 X's. And the last one, we will put 1 X because we have 1 athlete that jumped between 151 to 200 centimeters. Second graph, we use dots to represent one athlete, so instead of using X's, we will use dots. Last graph we have, which is the most important one, is called bar graph. It uses colored bars to represent data. So as we see, the range from 0 to 50 centimeters, we have 10 dark green bars, and the range 51 to 100, we have 7 red bars. The range 101 to 150, we have 2 orange bars. And the last one, we have 1 light green bar. Circle the option that communicates these data the best. Now look at page 9. Do you remember the data that Miss Sarah collected? The table at page 7. Let's look at the table. We want to present or communicate this table. I will choose the bar graph to communicate the data I have. Okay, I will represent my data using bar graph. So I drew bars so I can represent the data in the table. First, I have 3 students in the range from 0 to 40, so I will shade 3 bars. You can use your colors. The second range, I have 5 students, so I will shade 5 bars. Third range, I have 4 students, so I will shade 4 bars. The fourth range, I have 2 students, so I will shade 2 bars. And the last one, I have only 1 student, so I will shade only 1 bar. Let's answer the questions. What range had the greatest number of students? Excellent! From 41 to 80 centimeters. The second question. What range had the least number of students? Excellent! More than 160 centimeters. The last question. What information may be missing from your graph? The height of the students, the weight, and their names.